Hey guys, in this video we're taking a look at another type of a transformation, and the one we're taking a look at is called a reflection. A reflection is just a mirror image of a geometric figure across a line. And that line is called the line or axis of reflection, and it's the line that an image is reflected across. So if we're looking at a picture, let's say we have a triangle here. This is our pre-image, or our old one, and then if it's reflected across, let's say we do the y-axis, it's going to be a mirror image, so it's going to look exactly the same shape, same size, just reflected. It could be flipped, it's going to be flipped, but it's going to be reflected across the x-axis. So if this is A, B, C, this is going to be C prime, this one's going to be B prime, and this one's going to be A prime. So there's our pre-image, and here's our image. So this right here is our reflection. It's what happens after you moved it across the line of reflection. That's our line or axis of reflection. And whenever you're doing these, the easiest and quickest way for most of the problems that you get is just to count how many spaces is the original point away from your line of reflection, and then the new point or your image point is going to be the same number of spots away. But sometimes either the distance is too big or all they give you is points, and that's where these rules come in super handy. There's 6 different types of reflections that we can do. Only 4 of them have rules that you're expected to know. The rest you would have to count on a graph. So if you've got an x-axis reflection, and if you're looking at an x-axis reflection, that's going to be across this axis right here. You're going to have your original point, so these are going to be your pre-image. And then these are your image points, or your new ones. So this is what you're given to work with, and then that's the new one, the new point that you would write. Your x values are going to stay the same, and you're going to do the opposite of whatever your y value is going to be. If you're looking at a y-axis reflection, y-axis is going to be the vertical axis. From your original point, you're going to do the opposite of your x value, but your y values are going to stay the same. Looking at y is equal to x, so when you're doing y is equal to x, it's a diagonal line that has a slope of 1, because 1 over 1 in front of the x, so up 1 over 1, up 1 over 1. And for that rule, you're just going to take your x and y's and you're going to switch them. So for y equals x reflection, it would be reflected across that line right there. And then last one is a y is equal to negative x reflection. You've got your x, y, you're going to flip them and you're going to do the opposite of whatever value that they are. So there's the y equals x reflection. So all of these that we have right there, all of those are going to be our line of reflection. And it's kind of like the line where you would take the paper and you would fold it in half and then rub it and then get the image. It's kind of like the ones that you did in elementary school or middle school where you would color something in crayon and then take it, fold it in half, and then rub the other side of the paper and then open it back up and you get a reflected image of it. This is the same exact thing. We're just doing it with geometric shapes now. Yeah. Okay, so to start looking at some examples. The first 2 examples are going to be the ones that don't really have any rules to go with them, and you've got to count in order to be able to get them. They could still ask you to write the points, and then the last 4 are going to be the ones where I'm going to use these rules right here. Okay, so looking at this one, graph the line of reflection across y is equal to 2. Write the coordinates of the image. So first thing you got to do when you're looking to graph the reflection is you've got to find that line of reflection. So for this one, they're looking for y is equal to 2. And most people have trouble remembering, well, is that the vertical line or is that going to be the horizontal line? And the way I remember is, if I look at this equation, what variable is the only variable in there? It's going to be y. Where is y equal to 2? Right there. So now we have to draw the line so that it will only ever touch the y-axis. And if we do that, it would have to be a horizontal line. Because if we put it at any type of an angle, then it's going to end up hitting the x-axis at one point or another. And with these, we never want them to touch because there's no x value in the equation. So there's our y equals 2. So now we just count. Well, let's start with f. How far is f away from that line of reflection? It is 1, 2, 3. So we go 1, 2, 3 away. So 1, 2, 3 away, 1, 2, 3 away. So this one's going to be called f prime. And if we do that reflection, f prime is going to be -5, -1. So we'll do E next. And E is 1, 2, 3 away. So right above, straight up. So it's going to be 1, 2, 3 away, straight down below. So this one's going to be E prime. So the points for our E prime are going to be 4, -1. Looking at D, D is 1, 2, 3, 4, 5, 6 points away below. So when we make our new D, it's going to be 1, 2, 3, 4, 5, 6 points away above. So that one's going to be our D prime. So D prime is going to have coordinates of 3, 8. Looking at C prime, this one is just like D, going to be 1, 2, 3, 4, 5, 6 points away. So 1, 2, 3, 4, 5, 6 points above. So there's our C prime. So C prime is going to have coordinates of 1, 8. And if we connect our dots, it will give us our image. So there's our pre-image points, and here's our image points. And again, there's no rule for these. You have to count and graph. So looking at this next one, this one wants us to graph the reflection across x is equal to -3. Well, in order to be able to do that, we're going to have to find x is equal to -3, and x equals -3 is right there. And if we look, there's no y in that equation at all. So to be able to graph that line, we have to graph it so it will never ever touch the y-axis. And to do that, that's going to be a vertical line. So there's our line of reflection at x is equal to -3. So if we start reflecting these, let's start with P. So P prime is going to be, well, P is 1 to the left of our line of reflection, so the new P is going to be 1 to the right. So that's our P prime. So we're looking at -2, 2 for our new P prime point. So then we're looking at, let's do Q next. So Q is actually physically on the line of reflection. So it doesn't have anywhere to move because it's 0 away from the line, so it has 0 to move. So you still write it as Q prime. That way you tell people, hey, I've thought about this. I know this stays on the line, but here's the new name for the point so that you know that it's there. So there's our -3, 2. Next, doing the R prime. And again, it's a point that's on the line, so it's going to stay there and be -3, 3. And then S is 1 away from the line to the left, so our new point is going to be 1 away to the right. So there's our S prime. Ooh, and I forgot the R prime. Make sure you get the R prime in there. And then, so our S prime is going to be -2, 3. So there is our new image there. So there's the image. There's the pre-image. So that's how you do those whenever they give you a y equals number or x equals number. So when we're looking at reflecting across the y-axis, it's still the same exact idea as above. We're still working with, we're looking at our y-axis. So our y-axis is going to be through there because that's what our y-axis is. It's right there. So with these, it's going to, same thing as above, right? C is going to be 2 points away from that line, so our C prime is going to be 2 spots away from the line of reflection. D is going to be 1, 2, 3, 4, 5, 6, 7, so our D prime is going to be 1, 2, 3, 4, 5, 6, 7 the other way. And then B, 2 away, so 2 away here, B prime, and then A is 1, 2, 3, 4, 5, 6, 7, so A prime is going to be 1, 2, 3, 4, 5, 6, 7 this way. So we connect our dots. There we go. And again, just like I talked about last time, whenever you're graphing these on a computer, make sure that if you start with C and then go to D, make sure you go to A. If you go to B, you're going to get everything crisscrossed and mixed, and it's not going to be a nice, neat graph or a rectangle like you're looking for, so be careful. With these, though, you can be just given the points, and from the points be able to write the new points or your image points. And the way you do that is you're going to use your rules. So this is my A. It got cut off. So this is our original XY point. So they want our reflection across the Y-axis. So there's our Y-axis reflection. So this is our pre-image. So these are our original points. So this is the pre-image. So we're going to take this point and we're going to make our image, and we're going to change that point. And the way we're going to change it is all our x's are going to be the opposite of whatever they are, and all of our y's are going to stay the same. And the big thing about these is these are opposites. So if this value here is a -2, this value is going to be a +2. If this value here is a -2, it's going to be a positive. So, or if this one's a +3, then this one's going to be a -3. Whatever you see, you're going to do the opposite of it. A lot of people make the mistake of seeing that negative there and saying, oh, okay, so whatever there, no matter what, it's going to be negative. That's not the case. You need to think of it as it's going to be the opposite of. So if we try this out, A prime, what is the opposite of the x that we have? Well, the opposite of a -7 is a +7, and our y values stay exactly the same, so it's going to be a -4. Looking at our b value, b prime is going to be, we're going to do the opposite of the x, so opposite of a -2 is a +2. Our y value is going to stay the same and be a -4. Looking at our c value, our c prime value, we're going to do the opposite of the x. So opposite of a -7 is a +7, and our y value is going to stay the same. It's going to be a 6. And then our d prime value, opposite, because it says the negative in front, opposite of a -2 is a +2, and then the y value stay the same, so it's going to be 6. And we can use these points to double check with what we've done up here. If we've done this correctly, these points that we got from using the rule should match up exactly with the points that we have by doing the picture. So if we look, A prime should be 7, -4, okay. So then B prime is going to be 2, -4, doing good so far. C prime is going to be 2, I wrote that wrong. This should be a -2. So that would make this be a +2. So our C prime is going to be 2, 6, okay? So then D prime, I think I typed that one wrong too. Oh, that's the one that should be a -7. Yep, this should be a -7, which would make this be a +7. Yep, got those switched. So then our D prime is going to be a 7, 6. So that's a way to do and check and make sure you've got everything in line. And again, yeah, it's easier just to count it on a graph, but what happens if they didn't give you a graph and they just gave you the rule, or just the points? You would have to use the rule to be able to do that. So looking at the next one says graph a reflection across the x-axis and then write the coordinates of the image. So if we're looking x-axis, it's going to be the horizontal one. So again, just like before, we're counting how many away. For here, we do the same thing here. This one, we're looking at S. Well, we'll start with P. P is 1, 2, 3, 4, we'll count this way. How many away from the line is going to be? 1, 2, 3, 4, 5, 6, 7, 8, 9. P is 9 away below, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 above. So this is going to be P prime. So next we'll do Q. Q is horizontal with that one, so it's also going to be 9 away. So it's going to be 9 away above. Q prime goes there. Looking at S, S is 1, 2, 3, 4, 5 away from the line, so it's going to be 1, 2, 3, 4, 5 away from the line above. So there's our S prime. And then the R is also going to be 5 away, so there's our R prime. So there's our reflection across the x-axis. And again, just like the reflection for the y-axis, just like the reflection that we had with the y-axis, we had a rule. We've got a rule that we can use for the x-axis too. So if we use that rule, we're going to take our original point, which is xy, and looking at the rule, x-axis reflection, x-axis reflection is there. So we're going to take that y, xy, the pre-image, and all of the x values are going to stay the same, and we're going to do the opposite of the y value. So if we do that, and I'm not looking at the graph to do this, I'm just going to use the rule, and then that way we can use those two to compare and double check. X values stay the same, so 2. We do the opposite of the y. The y is -9. The opposite of a -9 is a +9. Looking at our Q prime is going to be x values stay the same, so we've got 7. Opposite of the -9 is a +9. Looking at R prime, x values stay the same. We do the opposite of the y, so 5. And then S prime is 5, because our x values stay the same. We do the opposite of our y values, so the opposite of a -5 is a +5. So we use these to double check. Looking at P prime, 2, 9, okay. Q prime is 7, 9. R prime is going to be 10, 5, and S prime is going to be 5, 5, so it matches up, so we did just fine. You could also do these the other way, and I'm going to do it the other way with these two examples right here. With these, we did the graph, then did the points, and used it to double check. You can also take the points, use the rule, and then use the rule to graph your image. So if we're looking at this one says graph the reflection across the line y is equal to x. So if we're looking at our line y is equal to x, remember it's up 1 over 1, so it's pretty much going to be a diagonal through those boxes. And with this diagonal line, it's a little harder to count across too, so that's why I just like to go ahead and use the rule and do it that way. So we're going to take that original xy, and I'm going to find the y is equal to x rule. Y is equal to x reflection. You take your xy and you switch them spots. So you write your y value first and then your x value second. So to find S prime, we just switch them. Just like they'd switch the letters there, we switch the numbers there. So instead of -4 coming first, it's going to be -2, -4. T prime is going to be 0, -4. And U prime is going to be 6, -3. So we can take these points and go ahead and graph them up here. So looking at S prime is going to be -2, -4. I'm going to label that one S prime. And then 0, -4. And then U prime is 6. Oh, I didn't switch those. -3, 6. So -3, 6. So there's our U prime there. So if we connect the dots, there's our new graph. And some people are able to see the diagonal and count the diagonal, like starting right there, and count 1 that way, 1 that way. And then if we go diagonal, it's 1, 2 that way, and 1, 2 that way. And then for you, it would be 1, 2, 3, 4 one way, but then it's a half and then you're not really sure. So half and then 1, 2, 3, 4. Some people don't have any problem doing their reflection that way. I find that most people do, and I tell them just go ahead and use the rule. And then once you use the rule to get the new points, then worry about graphing them on there. But if you can see it, go ahead and do it, unless it tells you to write the coordinates of the image. Okay. So looking at the last one that we have, for graphing the reflections before we get into just worrying about the points, this one says graph the reflection across the line y is equal to x. So y is equal to x is kind of the same exact idea as y is equal to x, except instead of having a positive slope, it's going to have a negative slope. So if we draw that in there so that we can see it. And again, I'm just going to go straight to using the rule and then graph the points. So we take our original points, x, y. Given x, y, we're going to do the opposite. We're going to switch the points, and then we're going to do the opposite of what we're seeing. So for our t prime, we switch our points, and we do the opposite. So 6 is going to come first, and it's the opposite of a negative 6. So the opposite of a negative 6 is a positive 6, and then the opposite of a negative 9 is a positive 9, and that's going to be our t prime. Looking at u prime, y comes first, opposite of a negative 6 is 6, opposite of a negative 6 is 6. Looking at v prime, opposite of a positive 2 is a negative 2, opposite of a negative 6 is a positive 6, and then w prime, opposite of a negative 2, remember because all our y values are coming first and we're doing the opposite of them, and then opposite of a negative 9 is a positive 9. So now to go and put these on the graph, we're looking at t prime is 6, 9. And then we're looking at u prime is 6, 6. And then looking at our v prime, negative 2, 6. And then w prime, negative 2. And again, when we're doing these reflections, the shape should stay exactly the same. The side length should be exactly the same, and the angle measures should be exactly be the same. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. So doing okay at least that far. And then again, I forgot to label one, UV, W prime. If you take this and you fold it, it should overlap exactly. And if you look, the V's are going to overlap, and the W's and the T's and the U's. And you could also count diagonally like I showed you before. 1, 2 that way, so 1, 2 that way. 1, 2, 3 and a half, half, 1, 2, 3. They could also just give you points. And given those points, it's going to ask you what type of a reflection that it'll do. Now, I think the exercises that you have, it only asks you, at least for me whenever I went through and looked at them, it only asks for the x-axis and the y-axis reflections. You could honestly get problems where they also do y is equal to x and y is equal to negative x as well. You would use the same exact process and match up the rule. So whenever I do these, I don't look at these rules at all. I look at what they give me and what I have to work with. So this is the original point, the pre-image, and I know that because it doesn't have a prime. So this is going to be my original xy. And then if I look, the x is still in the same exact spot. 2 is here, 2 is here, except they did the opposite of what they had here. So this is the opposite of x, and the y's are going to stay exactly the same. So if we go back, now we go back and look at the rules. So I'm not looking at this part, we're looking at, we went from xy to negative xy. So there's xy to negative xy, so that's going to be a y-axis reflection. Looking at the next one, xy there, and then here, the x values are exactly the same, so it's going to be x. And then the y, the numbers are still the same, but they did the opposite of the number that they have there, so it's going to be x opposite of y. So again, if we go back and look at the rules, we've got x, y, x, negative y. So x, y, x, negative y, that matches up with an x-axis reflection. So there's you some examples of how, given points, how you can find out what the rule is, and then given points, use the rule to write the new points, or given a graph, being able to make a new graph and write the new points from there. If you have any questions, be sure to write them down and ask when you get to class.